Hello, everybody. Welcome to the webinar. We're going to hold on a little while until everybody can join. So we'll start in about 2 minutes. Okay. So yeah, everybody, thanks a lot for joining the webinar about how to enhance the resolution of our multispectral imagery, making use of the black and white panchromatic bands. So let me present myself. I'm Erik de Bats. I'm working for Giggle since 2016. Used to be Mica Sense, of course. I'm based here in Latin America, but I currently am the sales manager for Europe, Africa, and also Latin America. Giggle, the company as a whole, now consists of different products. We have the sensors that we launched this year. Beginning of last year was a dual launch of the Red Edge P and the Elton PT, and this year we launched the Red Edge P Dual. We have the drone part with the EVs, established the fixed wing drone brand, and of course also the software. For those who are working already a long time with our sensors, they know we used to have Atlas software for visualizing and processing the imagery. That's discontinued, but the follow-up for that is Measure. It's not only just visualizing of the maps, of course, and processing. It has a whole lot of more features, and processing the maps is just a little part of it. But in any case, is a good alternative to visualize our data in a good way and share these data with the rest. So today, what we're going to talk about is about what's pansharpening about. What's the advantage of pansharpening versus RGB cameras, right? Because RGB camera, you just have the RGB camera picture, high resolution, you have it right away, and now you have to do the whole process of pansharpening the imagery. It's more work, that's right, but why is it better? So that's what we're going to talk about. We'll also talk about some use cases and applications, talk about our cameras, and how to process the panchromatic imagery. Of course, there we got at the end of the meeting some questions and answers. So please, if you have any questions, you can put them in the chat box, and we'll get to those at the end of the webinar. So before we begin, as I explained the questions, and after 24 hours, you will have a recording of the webinar and also a PDF, and a copy of the slides, which you can use, of course, mentioning the credits of our company. So yes, my name is Erik de Bats, and I will start with the webinar right now. So this is a very interesting picture. The marketing team put together some quite good slides to explain this, because for those who are already familiar with satellite imagery, they know about the process of pansharpening. It's a technique used already for many years, but for now it wasn't present for aerial photography, and also not for and even less for drone photography. And our products are like the first ones to make use of this technique, which is at first looks a little bit like difficult to understand why, but there are some clear advantages to do this. So what you can see here is a soybean field. With on one side you get the pan-sharpened RGB composites, and on the other side pan-sharpened NDRE imagery. You can only appreciate the true value of the pan-sharpened imagery when you compare it to other imagery, of course, or whether not yet pan-sharpened or from other kinds of sensors. So what is panchromatic? Pan is, it englobes all. So it's a classical black and white picture. We have these already for more than 100 years, of course, and all light, not only all visible light, but also ultraviolet light and near-infrared light will come through the lens all together, right? And depending on the intensities of the different channels, that's how we're going to get our black and white image. Yeah. So it's no filter at all. We get all the light through. Visible light is only between 450 and 650. The blue, the green, and the red, that's what you can visually see. And then after 650, we got the red edge and the near infrared, and under 400 is ultraviolet, also not visible for our eyes. So here we got visualized the typical five bands we have in all our sensors. The blue, the green, the red edge. Our cameras are called red edge because our company was like one of the first ones to see the true value of the red edge for drone mapping, and still one of the onlys who have also a blue band, right, to compose the RGB band. So here is a little bit an explanation of our camera, right? We got for the red edge P and also for the Altum PT, if you don't take into account the thermal channel, we got 6 different cameras. The blue, the green, and the red. If we combine those, we get to an RGB image. We got the red and the red edge and the near. We can switch between these bands to make false composites. And we have the high resolution panchromatic band. So I think it's nice here because here, for example, if you combine the red edge and the near, you get a non-DRE band. And the panchromatic band, which is the black and white, has more pixels. So actually, if you want to have the same pixel size for the NDRE and the panchromatic band, the image would be much bigger, of course. Yeah, because the panchromatic band for the red edge P has the double amount of megapixels than for the multispectral bands. So you can either do it in two ways, or you can do the panchromatic process for each picture. So you join the black and white picture with each of these 5 bands and have high resolution pictures for each of these bands. Or we can first make a map using the 5 multispectral bands and separately make a band of the panchromatic band and then join it. So that's the way Pix4D and Metashape do it actually. And there is a reason for that. That's because the lower resolution multispectral imagery will process much faster with a lower resolution. So if we do the pansharpening first prior to the stitching, we will need to work on much more gigabytes. That would be like working with 5 panchromatic bands, and these are 4 times as heavy in terms of gigabytes than one multispectral image. And that would also mean that we don't have no reason at all to have a panchromatic band, because we can have the blue, the green, the red edge, and the near band with a higher resolution, with the same resolution and as the panchromatic band. But that would mean lower capture rate and lower processing rate. So these are the key why we work like this. We're gonna see it later on in this presentation schematically. So why the real advantages work in this way in terms of efficiency in your workflow when mapping with multispectral cameras. So as you can see here, the pansharpening process gives you an RGB image. So I think we talk here about 2 different advantages. One is people ask many times, why should I combine the blue, the green, and the red band instead of having just an RGB camera? That's a very good question. And the reason is that the RGB images you can make with the blue, the green, and the red band are looking much better. If you are used to work with microsense images, one thing you will notice is the brightness of the images, the high contrast of the imagery. And that is mainly because of the filters, the narrow band filters. There is no overlap between the blue and the green or the green and the red. They're separate. So the light is very bright. And despite the maybe sometimes lower resolution than you can compare with other multispectral RGB images, it is very, very bright. And that makes enhances the ability to distinguish very well one pixel from the next one. And secondly, if you then do also the pan sharpening process, you can get the same resolution as you can have with an RGB image, not only in this terms of pixel size, but on top of that, with a much higher contrast. Yeah. So that means, for example, with this technique here, what you could get to is like comparable to a 12 megapixel RGB camera, but because the contrast is so much higher, you can easily compare it with a 20 megapixel RGB camera. Yeah, in terms of analysis and visual interpretation of the images. So here you can see a little bit the difference. So on top here you have the Ultimate PT image before pan sharpening and below after pan sharpening. So you can clearly see here you have the figures of the plants, and you can see directly each and one of them of the independent leaves. And if you would really close up, you can actually see the contrast of the image between one pixel and another, which is really, really good. So I talk to people that are really going for the resolution, right? For plant counting specifically. I say, no, I need 40 megapixels of resolution because I want to see spots on the leaves. Okay, right. That's the megapixel story. If you work with pan sharpening Ultimate PT images with a very high contrast, maybe the size of the pixel is a little bit less than a 40 megapixel camera, but because of the high contrast, you can get even better results because you can distinguish much better one pixel from the other one, while a normal RGB camera, as it says, 40 megapixel RGB camera has one red pixel, one green pixel, one blue pixel. So to start with, you have to divide it by 3 to get to the real resolution. And then there is also the pixel mixing. So it's quite technical on how an RGB camera works, different from how our cameras work. So the advantages. Right now in the market, you can find 3 different types of configurations on how to enhance the resolution of multispectral imagery, right? So the first one is working with one of our sensors, and on top of that, work with a high resolution RGB camera jointly. Many companies do that. It's good. Companies like Syngenta, Bayer, I know they're doing that. There are OEM manufacturers, drone manufacturers that are able to carry 2 sensors at the same time. So it's good. But what's the disadvantage of that is that your bands are 2 different cameras. So you have to make 2 different maps. And after that, these 2 maps are not really aligned one to the other. So you can't really superpose them on a pixel basis, on a pixel resolution. Then, secondly, we have the dual RGB multispectral camera. So this is a very popular option. It used to be always in the market. To give it a name, it's the Parrot Sequoia camera. Looks exactly like this. And now as well, the Mavic multispectral from DJI has also this option with 4 multispectral bands, and in the same device, high resolution RGB camera. And strangely enough, both have the same, almost the same configuration and but also the same disadvantages, which are, first one, it lacks the blue band. It's not needed because usually the blue band, you need that to make an RGB image. But if you are working quite a while with this multispectral imagery, you want to have the blue band. You see the advantages to work with RGB data with narrow band RGB data for the contrast that you want to have, the brightness of the imagery, and also for certain applications. Blue band is always interesting. It has a little bit of bad fame, the blue band, because historically, when we work with satellite imagery, we would say no, we're gonna work with the blue band because it has too much backscatter from the sky. That sky is blue because it gets reflected into the particles in the sky. So when it gets here down to Earth, it's too contaminated. So we're not going to use that band. But when we work with drones, we can perfectly use the blue band. We can have it calibrated. We can have correct radiometric information for the blue band as well. So it's not a band that we should not use for analytics. We should. And on top of that, with this RGB camera, although it's in the same housing, it's not aligned, and you have to process it differently. Two different processes, and the bands are still not aligned. So you always have to work with your multispectral data on one side and your RGB map on the other side. Actually, same as separate RGB and multispectral cameras. So that's why we came up with this solution to have it integrated with a panchromatic band. So here we have a dilemma, of course, because we were thinking about it. Okay, what are we going to do? Are we going to make, because our camera, the Red HMX, had only like 2.5 megapixels for each camera, multiplied by 12 megapixel camera. People say, yeah, we are looking for better resolution. We want better resolution. We want to see this and this and this. We want to apply computer vision. We want to apply artificial intelligence algorithms. We need to have object recognition. We need more resolution. Okay, good. So we can do that. We can put 5 high resolution cameras with a filter on it, but that comes with a cost. Monetary cost, it's more expensive, of course. And secondly, it's a lot of information. It's a huge amount of data. And it's not that we can't do that, but that makes that your camera will be bigger. It will produce more heat. It will consume more energy, and it will also be slower. And when the capture rate is getting slower, it means you need to fly higher or slower, and productivity goes down. So that's the first reason that we say, okay, we'll try out to put a high resolution black and white camera with a fast capture rate. Now with the Red HP, you can take up. I've tried. Okay, the specs comes with 3 pictures every second. I've tried it out, and it gets to 4 as well. So that means you can fly first very low and very, very fast. So I'm going to show you here an example now with of a field we flew with the Wingtra 1, the VTOL, which flies really fast and at 60 meters above the ground. You need very high capture rate. So that's what we did, and it works perfectly. So that's the big advantage here. We could keep the price relatively low, still not a cheap camera, of course, and but with a very high capture rate, and that's the important. And with a lightweight, so we can take it on any other drone. At the same time, we came up with a new product where we actually put higher resolution lenses for the multispectral options, and an even more higher resolution for the panchromatic option, which is the Altum PT. Yeah, we're going to talk about that later. So here you have an overview. If you want to check out later on what are the advantages and the disadvantages I've just exposed. So some more benefits of the camera. It increases the resolution and the accuracy. It allows advanced applications such as artificial intelligence and computer vision on the imagery. No need for separate RGB camera. Faster data capture and post-processing. Yeah. I think these are the last point is like the most important one. You can take quickly many pictures, and we can process quickly the data. It comes with a cost, of course. There are other options in the market. In this case, right now, I think our biggest competitor would be the Mavic DJI, which comes at a very good price point. But I've seen the data. It's a huge amount of data. It takes a while to process everything. It doesn't take pictures as fast. And we, of course, priority number one is data quality. So we can make the data comparable over time. That's the reason our company is still here. And that's the reliability of the data. It comes still with the calibration panel and with the DLS2 for the direct light incidence sensor for direct light conditions correction. And that combo makes that our camera is still standing here as the best option in the market. And that's why I just needed to explain a little bit better the option of the pen sharpening, because many people are not using it because it's like an extra step, which I understand, but the whole reason for this webinar is to explain that it really brings some extra value, and it's not that hard to do, especially if you talk to if you work with Pixworthy Fields or Metashape. It's just a workflow. It's on our webpage on the support. Just put Mica Sense Panchromatic, and you get an explanation on how you can, with some mouse clicks, you can get directly to your pan sharpened data. So here we got some user cases. So here we got a strawberry field, very small plants for plant counting. You can get that for cornfields as well. Very important to have the counting of the plants, and people use our camera for it. Sugarcane also very important for the plant counting. Currently, people will say, okay, I just need an RGB camera because I just need the resolution. Okay. Nevertheless, it's not just the plant counting, because you also usually want to know how your plants are actually doing. So what we do here is we have here a technique. Everybody can copy it. Is to first count the plants, then have an idea about the size of each plant, and then for each plant, take out the NDVI value. So then you know if you have plants or not, how big are these plants after emergence, and whether they're good or not. So all that you can do just with one flight with the Red Edge P, for example, and have all that information and get row by row all the information on the three variables: amount of plants, size, the mean size of the plants, and the total biomass of each plant. You got another one. This is on the pumpkin side of things. Pumpkin field in Washington, Seattle, where we used to have our office. Nice application as well. This is the field I was talking to you about that we did with the Wintra 1 here in Argentina. Get very bright RGB composite. That it wasn't just a sunny day. It's also the camera that gives that very typical imagery that we can make very good lines of the difference, the contrast between what's a plant and what's not a plant. As you can see here, the NDVI trees, where we can just put a threshold on the NDVI to distinguish the tree from the surrounding soil. Now we can distinguish each tree from the other one. That's the size of the circle here. It's how big is the crown of the tree. And then the color of each circle is the mean NDVI value of the pixels that are consistent of that particular palm tree. So here on the right side, you can see the entire field. On the borders, you can see that there are bigger trees and more trees. That's basically because the owner of the field left the trees there to protect the trees on the inside of the field for wind, basically. So it's more like a windshield they have there. Some more applications: quantification, 3D volumetric calculation. With, for example, if you have, our camera is not only used for agriculture use, also for much environmental uses and even for construction. And a good DTM or digital elevation model is always needed for all applications. Any applications you're working with land management, you need to have an elevation map. And with the high resolution of the panchromatic band, you don't need colors to make a digital elevation model. You just need to have the X, Y, Z information of each point, and that you can get with the panchromatic band as well on a very high resolution. Biomass and leaf area computation, stand mapping, classification, plant counting, crops counting, species identification, now enhanced with the new dual camera that came out. So you have now 10 bands, plus the panchromatic band for the pan sharpening of all pan bands. Ideal tool for species identification and land use classification. So these are our sensors that we're having right now. This is our entire portfolio. So with some very, very basic specs here on what's the resolution after pan sharpening at 60 meters or 200 feet above ground. So for the Altum PT, P is for the panchromatic and T is for the thermal, because it does have a thermal channel. It's 1.25 centimeters on 60 meter. Yeah, and as I say, with the high contrast, the Altum PT, the RGB images you can make with this camera are comparable as what you can do with a 40 megapixel RGB camera. The FLIR, the thermal part of the thermal channel, hasn't that much of a resolution, so that's 10 times more. So at 60 meter, you have 15 centimeters thermal resolution, but fully synchronized with the rest of the bands, and you can process it in one time, both in Pix4D fields as in Metashape. You can have it just as another band. There is no reason to do pan sharpening on the thermal band, however, because the difference in resolution is too big, right? And you would really lose some information or related to the temperature of values of each pixel. The pan sharpening only applies to the 5 multispectral bands. But HP and the combined cameras. So for the blue one, we disabled the panchromatic band, of course, because it's okay to have just one. And you have the 10 other channels for multispectral mapping. So why are MicaSense cameras different than all the other ones? Why we are still the standard for multispectral mapping with drones in the world? First of all, is because thanks of this panchromatic band, you can respond to a demand we had already for many years. That's what about the resolution? We want to have a better resolution. We have an answer for that better resolution through pan sharpening. So key point to take away here: we can keep the very high capture rate. We can keep the data quality, enhancing the resolution. Yeah, and the way to do that is through pan sharpening. Data comparison over time, that has to do with radiometric accuracy of our data. CRP comes with it. The DLS2 is a very good tool for cloudy days. You can compare pixel by pixel between sites and over time for the same site. Completely reliable. Accurate results. The bands are very narrow, no overlap between the bands, fast capture rate, and it is integratable with all drones. Our cameras are still drone agnostic, so it goes with DJI drones, it goes with Wintra drones, it goes with quantum system drones, Delta Quad, name it. Any drone which is physically capable of carrying our sensor has an integration option for it. Also for the software side of things, most renowned softwares like Metashape and Pix4D, we work closely with them, and they can process all our sensors and give reliable information. So that's it for the presentation. took only half an hour. I think that was enough time to express the idea of pan sharpening. And if you have questions, I'm happy to answer these. All right. So if there are no questions, I can only. Oh, here's a question. Let me see. The FLIR thermal sensor camera has a specific software to extract the thermal values. Okay. There is sometimes a little bit confusion on this, but the answer is very, very straightforward. Our camera gives the exact thermal values, but in Kelvin. If you want to have them in degrees Celsius or in Fahrenheit, you need to convert them. So it comes in Kelvin degrees. So I don't know really by heart what the conversion rate is, but it's on our support page. Put on Google Altum PT or just Altum convert thermal values, and the formula should pop up. So let me see here. Another question. At the end of the webinar, yes, you can have the PDF and the presentation. In 24 hours, you should get that. Can the blue band be used for agricultural processes? Yes, it can. It has very similar reaction for the plants as the red band. As you can see, plants use both the red light as the blue light for the photosynthesis. And a lot of research have been done on how it works with the red light and not as much on the blue light. So we can see increasingly more and more scientists and people interested in see if we can get some additional information from the blue band. So I think that's the interesting part here for agricultural research. And as I said, since the blue bands from satellites isn't really reliable because of the backscatter in the air, there is not so much work done. But now with our sensors and that we can use more close range imagery, it is used more and more. So when you have taken pictures at 60 meters, how fast were the drone flying? So right now, that's also interesting. We have a calculator on our website. Yeah, so you can put the camera you want to use, and you can put the speed of the drone. You can also say it's a multi-rotor or I have a fixed wing drone, and you can calculate how fast your camera will, how fast you can fly or how low you can fly with the maximum capture rate and how much gigabytes you will produce on that. So go on our website and look for the calculator, and it's an interesting tool to have answers on these. So can the Red Edge be attached to a PixHawk flight controller easily? Yes. Actually, by default, if you buy a camera with us, it comes in a box. So here I have a picture of what comes in the box. I used to have it somewhere. Here it comes. So what comes in the box? The light sensor, the camera, the lens cover, express card, the express card reader, the calibration panel, the hard case, the USB Wi-Fi, the quick start guide, and it's not mentioned here, but it also comes with all the cables for integration with PixHawk. On our webpage, you can also find the explanation on how to integrate it and to configure PixHawk so you can control the camera directly. Yeah. So Red Edge P easily swap between DJI and 350 and Wingtra 1. There are extra mounts and hardware required. So the mount for DJI, we can provide you that. Yeah, it's a quick mount or a skyport. We have two. The quick mount is just giving energy to the camera and mount. And then the Skyport option, it gives you also the integration, so you can work with the DJI Flight app and have access directly to the camera, and you can see each time the camera takes a picture. Wingtra provides the mount. So if you want to have the mount for our camera, for the Red Edge P from Wingtra, you need to buy it from them. But you can swap the camera, put on the Skyport, and put it on a Matrice 300. There is absolutely nothing that will not allow you to do that. The Jewel system is the only sensor capable of identifying individual species. Interesting question. It's not the only camera, because it depends on the species, of course. And if you want to differentiate one species from the other, you have so many very species that are lookalikes, you know. And if you want to tell the difference between one and the other one, there are so many techniques to do that. One is on the resolution side, if you're looking for a special feature. The other one is temporal, for example. If you want to distinguish two types of trees, two types of deciduous trees, you can fly one in summer and one in autumn, and you know, one will have leaves and the other not. That's maybe the only way to distinguish one species from the other one. But also, the more spectral information you have, the more accurate you can draw the spectral signature, which is unique for each species. Yeah. So it's interesting. There is a software. It's called Envy from Harris, and they have a spectral library. They built it up with many years of research, and we put one of our images in it from a forest somewhere in Oregon, I guess it was. And the spectral library matched with the 2 or 3 tree species. This is, I don't know which tree species grow over there, right? But the spectral signature of the 10 bands were just matching, and they could tell them the trees apart without any previous knowledge about which tree it actually was. So interesting. What are the IA programs you are using to crop stand counting, coverage biomes, etc.? Yeah, I wish I know. I wish I had time. I wish I had time to know what's actually going on. I used to know it much better than I do today. So many people are working on this. Normally there was like, okay, how do we classify image? We look from one pixel to the other, we do a pixel classification, then we came to object recognition. So to try to draw polygons around some pixels and make an object of it. Now we have IA, computer vision. I can only imagine all the possibilities we have, and I know many people are working on it. But right now, I'm not sitting in their kitchen, and I'm not really aware on how far they are pushing this, right? So the data can be used to access crop evaporation or when crops will be irrigating. Yes. There are companies doing this. It's a hot topic. If we talk about the applications of thermal data with the Altum sensor, people say, yeah, irrigation, water content, but if we can really start working with the evapotranspiration of the plants, we can have really accurate growth models of the crop. That's what we're looking for. People are looking into it, and for that, what you need is not only a good thermal sensor, of course, but also you need to have a good weather data. You need to what's happening on your field. You need to have very good control of the situation. But yes, people are working on it, and apparently it's working. And people try to adapt it on like crop growth models where evapotranspiration is a key part of it. Do we ship worldwide? Yes, we do. But also 90% of our sales go through local dealers. That's not more expensive than, because we give them quite good discounts, I would say. So the price difference wouldn't differ too much. But if you say, okay, there is no dealer in my country, you can buy it directly with us. For that, I can refer to you directly who you need to talk to. So in the sales team for the sensors, it's just the 3 of us here. So myself, I'm doing Europe, Africa and Latin America. Brian is taking care of North America and Canada. And Simon, he's based in Japan. He joined the company just a couple of months ago. He's taking care of APAC, but that includes as well India. So India, China, the Far East, and Australia and New Zealand. So you can write him directly an email with your inquiry, no problem. On the website, the calculator, it is written 2.72i. Is it because of the pan is not calculated? Probably, yeah. That's probably because the pan is not calculated. That's right. Something else here we got here. Will pan sharpening affect health, vegetation analysis accuracy negatively since it will alter its original value? Yes, it will alter the value. We've checked this out. We put it in a chart. There is a deviation, not always, but the overall and mean error it might give you after pan sharpening is between 5 and 10% of the reflectance value. That's why pan sharpening is very good to make an RGB image. But if you're doing vegetation analysis, I would not recommend do the pan sharpening. What you can do is do your analysis only on the multispectral imagery and use the Panchromatic high resolution band just to delineate the objects. For example, the example with the palm trees. Use only the pan sharpened RGB image or just the pan sharpened, just the Panchromatic band to see what the border is of the crop, and then use the original values of the multispectral bands to calculate NDVI values and DRE values or do any other algorithm calculations you want to do on the vegetation. Yeah. Okay, so I think we hit here the end of our webinar. If there are more questions, I will certainly send you an email with the answer. The questions are very interesting. Reach out if you have more questions at any time. We are here to help you. And yeah, one more time, thanks a lot also for the marketing team to put together this wonderful presentation, and to all of you to assist and listen to me during the webinar and having all these interesting questions. Thanks a lot. Have a nice day, everybody.